Okay, so in the last little mini lesson, we kind of went through how to create some basic data structures, how to do comparisons, how to do a few multiplications. We're now going to create something called a data frame, which is one of the standard methods of storing data in R. And we're going to kind of just doing a little example kind of employee data set where people have, maybe a few different attributes. So we have 10 employees. The first thing we're going to define is the gender, which can be female, male, or other. And we're going to define this as a factor. And a factor is really just like what you would call when you do business stats, what you call a nominal variable. It's not continuous. There's no real order to it. So something like ethnic group could be a factor. Your major could be a factor. Um, the type of job you could have could be a factor. But here we're just sticking with gender. So use the factor command. Again, you notice we use C a lot in R. We're creating this vector of 10 different genders, and we're setting the possible genders for level. So let's run that little bit of code and see what the result is. And you can see we got listed here these 10 people, male, male, female, 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 etc. And these are the three levels that are available for gender. So you could just say, gender and number 3, and we'd get female, and this could be a female, male, or other. Now, we're kind of these employees, we're going to have them do some sort of technical training, and they can get certificates. Maybe they did it with data camp. They can get certificates from this training. And so we have another piece of information set exactly the same of whether they have no certificates, whether they have a basic one, whether they have an intermediate one, or whether they have an advanced one. And the only difference here is we're going to put ordered equals true because there is some useful ordering information here. Basic is better than none, intermediate is better than basic, and advanced is better than intermediate. So the order these levels are actually have some meaning. If I had maybe 4 different job categories or 4 different degree majors, it would be very difficult to kind of order them. So we do exactly the same again, and we get cert level. And you notice how it shows the levels. We have this little less than sign, none, less than basic, less than intermediate, less than advanced. And each employee has an ID, and these are just going to be straight strings, so we don't have to convert them to factors. And we're going to create the salaries for these people, so they're going to have 10 salaries. And these are just going to be a list of numbers. Now, to create the data frame, we're going to call this data.frame, which creates the data frame. And we're going to pass each of these variables we previously created: employee ID, gender, certificate level, salary. Um, and we're going to put strings as factors equals false, which just means we're not going to automatically try and convert the employee ID into a factor. Whatever is a factor already is going to stay a factor, but we're not going to convert everything else. So they're going to click this and see what we have in employee data. And there we go. We just have this data frame. The data frame has 4 different columns. We've got the employee. It looks a bit like an Excel spreadsheet. It has employee ID, gender, the certificate level, and what sort of salary. So we see employee 5 is female, has an intermediate certificate, and earns $123,231 a year. Now, there's lots of things we can do with data frames. And you just play around with these. The str just tells you a little bit of information about your different columns. So here we have 4 columns. And we can see we've got employee ID, and that's a character column, gender, which is a factor, certificate level, which is an ordinal factor, and salary, which is numeric. The head basically gives you the first few items in your data frame. So we're going to put head, employee data, and 5, and this is just going to return the first 5. And likewise, tail would return the last, in this case, 5 items. So we return 6 to 10. We could also have n row. That's the number of rows. N column, the number of columns. And dim actually combines this before it returns, so you get the number of rows and the number of columns. One more I think I'll just add while I'm doing this is you can actually have the col names, which tells you the names of your columns, which is actually quite useful because if you want to change the names of the column, you can actually set employee names. And then the row names, unsurprisingly, gives you the name of the rows. And we've not really named the rows here, so these are just actually going to be the numbers 1 to 10 because we've not given them explicit names. But we could give these, for example, the names of the people. Okay, and just expanding kind of what we did last time, where we actually selected items from lists. Here we select items from data frames. Important thing to note, the comma. To the left of the column of this is selecting the rows, and to the right is the columns. If there's nothing there, that just means we kind of select everything. So here, we're going to select everything in the second column. And we just get basically the gender. The gender is the second column. If you look here, gender is the second column. And then we're just gonna, this would actually give you exactly the same because we can actually, rather than referring to column 2, we're referring to the gender column, which is column 2. So it gives you exactly, both of these give you exactly the same. Now drop equals false means, we're only selecting one column, so that's really just a vector, but we can actually keep it in data frame format. So now we have a data frame with just a single column. So here we have row 2 and column 2, which is male. So the second person was a male. And again, this will give you exactly the same to gender. Now here, we can actually list, we can have more than one column. So we do C to give the vector. We have 2, 3, and 4. This is basically returning the second column gender, the third column certificate level, and the fourth column salary. Now, you can also use minus notation. This is saying we want everything except the first column, which is columns 2, 3, and 4. So it's exactly the same as before. Now we want everything except the first row. And so we've got rows 2 to 10. Everything except the first 5 rows. So we have rows 6 to 10. And this is just another way of saying that, just another way of doing it. And here we're going to do basically everything except the first column. Now we're using the summary command, which gives you kind of summary statistics, but the first column is just a string. We don't really want any summary statistics on the ID. It wouldn't be meaningful. So summary is just basically saying gender, which is kind of a categorical variable. We have 5 males, 5 females, and 0 others. Cert level, we have 3 nons, 2 basic, 3 intermediate, and advanced. But you notice for the numeric data, it gives you something different. It gives you some summary statistics. Think back to probably stats 1. So you got the minimum, the middle value, the median, the average, the mean value. You also have the 25th percentile, the first quartile, the third quartile, and you have the maximum value. Now, we talked a little bit about logicals in the previous video example. So we can actually say, remember that we use the double equals and the not equals. So here we want all the again, still rows and columns. Rows is before the column, comma, columns is to the right. We want everything where the gender is male. Now, this is only because we've previously defined gender. You see here, we might, if we hadn't have done that, we'd have had to actually do employee data dot gender equals male. But this actually works because we've previously employed gender. And then we can say employee data gender is not equal to female, which gives us the same, gives us all the males. And then we want all the females, and then the and basically means we need both the left and the right to be true. So all the females who have intermediate level certificate. And we have 2 females intermediate level certificate. The next, the little straight line on your keyboard, this just means or. So we need everybody who's females or intermediate certificate, which actually returns quite a few more people because we get all the females plus we get the male who has the intermediate certificate. And then for these people, we could just have the salary. And that would give us the 6 salaries of the people above. Okay, so let's just kind of do a few more things. So the first thing to think about is ordering. And we can order by the certificate level. And what the order does is it basically actually gives you the numbers for the rows. So then we'd actually plug these numbers into the rows and it would return the rows in this order. So we're actually ordering by certificate level. So you can see we have the nons, the basic, the intermediates, and advanced. This is where it's important to actually have an ordered factor, because otherwise it would have tried to do it in alphabetical order, which would have been wrong. And then we have order in terms of salary. And if you've got something new, what we can also do is we can actually, by default, it does it increasing. We could actually we set decreasing equals true, and we got an order of decreasing salary. So here we go. We start off with the person with the highest salary, and then we go to the lowest salary. We can have the table command, and the table command basically summarizes the categorical variables. So we just summarize people by gender. So we have 5 females, 5 males, and other. We can summarize at a certificate level. And we can actually summarize by gender and certificate level. If we do pass 2 factors, you see here we have a little, if you remember from when you did the chi-squared tests in business stats, this is just like a little contingency table. So you can see that we have 2 males who have the basic level of certificates and 1 male with intermediate level of certificates. Now the next type of variable we're going to do is a list. And a list is kind of a special type of structure, and it enables to have items of any type in this list. If we had a vector, which we previously defined with C, we'd have to have all numbers or all strings, or all factors. A list allows you to have multiple different types of items. So we're going to create an employee list, which has a list with employee ID, gender, cert level, and salary. So it's actually going to be a list of these vectors we defined before. And let's just see what we have. So we have the first element in the list is the IDs. Then we have the gender. Then we have the certificate level, and then we have the salary. And in fact, a data frame is just a fancy type of list. So this is kind of the same element in the data. This is basically the same as a data frame, but structured a little bit different. Notice here, to get elements of the list, we have double brackets rather than single brackets for vectors. So we have the second kind of second element of employee list. Let's run. And that's the gender. Now, one thing you can't do, so if we went back to here, with the data frame, you can name the column. So we have employee data.gender. But this doesn't actually work for the employee list because we're not named anymore. We just have the list elements 1, 2, 3, and 4. So let's just get the gender. So this gets the gender. Now this returns a list. So we could, a vector. So we can actually take the first element of that vector it returns, and we'll say that the first person is a male. So let's add some additional information. Let's add the day these people started work at the company. So we have a list of dates. Now dates can be complicated. Dates have different formats. This format basically means we define a format for a date. This means we have a month, $M, then we have the day, and then we have the year. So you see here, this is June the 15th, 2018. In the UK, we actually have it the other way around. We have a day, so we'd actually be day, month, and year. Now, I won't go in. There's like a huge, literature on date formats. So we won't kind of go through that. We'll just do the basics here. So basically, we create start date, and this just gives us a vector of strings. And then we do conversions. In R, if you want to convert between data types, you do as dot the new format, and we have the existing dates with the new format, and we're going to click run. And you see here now, we've converted everything to a date. You've got to be careful when you convert formats, because it only really works if something actually fits. So if I did like, let's just do as start date, and then if I did as dot integer and start date, then you see it doesn't make any sense. It can't convert this date into a number. I'd have to have, like, if I did, so let's just say I did as dot integer, and instead I did C, and I have 1, 2, 3, then it would be able to convert those strings into integers. Okay, so let's just run that code. And we have the start date. And to add a new column to a data frame, we use cbind. We use rbind to add a row and cbind to add a column. So we put in the original data frame and the new column. And then we look at our new employee data. And you see we have employee data, gender, certificate level, salary, and start date. And what we're going to do now is we've added a column. So let's add a row. Let's add a new employee. So we're going to put add employee is a list. And we have to use a list. We can't use like C as a vector, because we have different types here. So we have their ID, we have their male, we have a basic certification, we have a salary, and then we actually have to pass in a date. So we have as.date when they started, which would just actually give us this date. And so this is our new employees, a list. And then we use rbind to add the employee to the existing employees. And you can see now, rather than 10 employees, we have 11 employees. So just a final little thing is we've got this beautiful data frame. We don't want to lose it next time we open R. And what we can do in R is we can just save our session to something called an R data file. I've got more details, a little bit more details in the notes on saving files and the different kind of file types that you get in R. So let's just kind of go back and let's just save this. So to save, sorry. To save, we basically do save.image. And this saves everything as an R data file, and it will save it in your current directory. So where we set at the beginning, we set to be BQA Analytics 2024, it will save the file in that directory. And that was just save everything you've got. So if we actually look here at the environment, we have everything we had before. And let's just kind of remove everything. This basically is a little command. This basically remove and list equals ls. That just lists everything in the environment. So you see we've removed everything from the environment. It's empty. But if we load this file, then we have everything that we had back before. So we can also kind of, let's just save, we can save one of our items. So we're going to save employee data in a file called employeedata.rdata. There we go. And let's do RM, which again is remove. And let's just remove the employee data. And you see we don't have any employee data anymore, but we can actually load it. So the files we use quite often when we're doing with R is a CSV file. And this is just literally all the data separated by commas. And for this, we'll use write.csv, employee data, and we'll give the the name of the file, employeedata.csv, and row.names equals false just means we don't save the row name. So let's just save that. And let's just kind of go back, and we'll go to R and BQA Analytics 2024. And you can see we've saved this employee data file. Let's just open it in Excel. Excel's it's taking a while to load. And there we have the file in Excel. So it's actually saved it in something we can open in Excel, or we could actually open it in Notepad. So let's just open it with Notepad. And here you can see it's actually a text file with all the items actually separated by commas in that text file. So it's just comma separated variables. And the equivalent of write CSV is read CSV. So let's actually remove employee data again. And we're going to do read CSV. Now notice we put strings as factors equals true. This means if we pass a string, we will convert it to a factor. And everything's a factor. But employee ID is a factor with 11 levels, which we don't really want because it's not really a proper category. Everybody's got a different employee ID. So we can actually do strings as factors equals false. Just play around a little bit with this. But now everything's a string, so we have to reconvert gender and cert level to factors. So now we do read.csv. Now we do an additional one, but we're going to do read.csv, and we define col classes. So we actually define the classes for each of the columns. So the first one's a column character, then we have two factors, then we have numeric, then we have date. And we can str employee data again. And this is pretty much okay. Notice cert level isn't an ordered factor. And this read.csv doesn't allow you to actually specify ordered factors. So we'd have to then go back and convert that to an ordered factor. But this is almost there. But that does show you that sometimes it's easier to save something as an R data file because you don't necessarily lose information. Okay, so just to summarize, we did a lot in this video. We created the data frame. We accessed various parts of the data frame, and we showed how to access it with logicals. We showed how to summarize with tables. We worked with lists, and then we kind of added a row and added a column, and then we worked out how to save the various files.